For this application of functions, what I want to involve is what is referred to as the rocket function, which I have written right here. And the rocket function, just so you have an idea of what we're referring to, and we'll talk a lot about it, the function part of it, the function notation, the R with the parentheses T, is just representing the fact that this is the rocket function. What the rocket function solves for us is the altitude of a rocket at a time of t. So we need that time of t in order to do this. The t for this particular function is time in seconds. So t, time in seconds. The f part of this is the launch rate of speed in feet per second. So we're going to be able to take this function, and working with time and working with feet per second, we're going to be able to have a good idea what the altitude of a rocket is going to be. And what I want to do for that is get outside and actually launch a rocket so that we have an idea what we're actually referring to with this. So we're going to head outside and bring some rockets with us. We're going to launch some rockets. So here's what we're doing today. We're going to be launching rockets, and I've collected some rockets over the years, and they tend to advertise different heights that they're able to travel. I've seen them advertised as high as 400 feet. Sometimes they're advertised to be 200 feet. So we're going to launch a rocket today and hopefully see just how high it maybe can go. And what I've brought out is a stopwatch. I'm going to do some timing on this particular launch. And just to explain how the launch works, this launch pad here is filled up with air. I'm going to jump on it, push some air through that hose, and send that rocket up. I'm going with the green rocket today, hoping that maybe it shows up a little better. Nice bright sky today. So we're just going to see what we can do with this rocket. Alright, looks like we got everything ready for our launch. I'm going to obviously start the stopwatch as soon as I can hit that launch pad, and I'll stop it when that rocket hits the ground. And if you can give me a 5 count down to the launch, that would be a help for me. So here we go. 5, 4, 3, 2, 1. Whoa, that one's up there. Oh, that came awfully close to hitting my dog. I'm glad it didn't. It came down pretty quick. I got a time of 4.814. That's what I've recorded on my stopwatch. A couple things to pay attention to. I'm glad that didn't hit my dog. That came down a little faster than I expected it was going to. The launch speed also, I'm glad that didn't hit either of us because it seemed to take off a little quicker than I was expecting. So anyways, I've got this time on the stopwatch. As far as trying to find out about these claims, 200 feet, 400 feet, it's hard to have any idea. I mean, looking up in the sky, I know it was up there. It looked like maybe it went taller than those trees. I'm hoping that maybe we can find out a way to figure out or get a good idea just how high that rocket went. Alright, now that we did all that and had some fun while we were doing it, these are the questions that we're trying to get an answer to. Obviously, how high did the rocket go? I mean, it was great getting out there and shooting off some rockets, but I want to get an idea of roughly how high the rocket went. They mentioned, there was mention in that video clip that the box that the rockets come in claim that they can go 400 feet high. Well, we have no idea what that is. We're going to do some math and try to see if we actually did that. And also curious to see what the launch rate of speed was for our rocket. So those are the 2 questions we're going to try to answer.